So last time we discussed this whole idea of equilibrium and the fact that really chemical reactions that we have dealt with, we talk about them generally in one direction because there's a direction that tends to be favored, but those reactions can, in fact, go both ways. All right, we can take the reactants and form products. We can also take the products and disassemble them to reform the reactants. Le Chatelier's principle explains when one side of the reaction is favored over the other. All right, so what kind of things you can do to force it to favor one reaction, the forward or the reverse reaction. So you're going to know that you understand Le Chatelier's principle really well when I present to you a possible change to the conditions of the reaction, and you can correctly predict what's going to happen. All right? This part here, heat being added, we'll actually discuss in more detail in next class. We're going to just, in this recording, we're just going to stick to the simpler way of thinking about this. So, Le Chatelier's principle is quoted as, any change to a chemical system at equilibrium causes the reaction to move in the direction that will minimize or offset the effect of that change. All right? So, really, you can just think about this. Whatever change you make, the system's going to try to reverse that change. All right, so if you remove something, the system's going to try to recreate it. If you add something, the system's going to try to use it up. All right? So that's kind of the gist of what's going on here. You can even think of this as, like, say, a balance, all right? So when we're in equilibrium, we're in balance, all right? We have this perfect ratio of our reactants and our products. It equals that equilibrium constant. And then if you were to, say, add some product, all right? So you're going to add some product here. We're going to increase that. That would force our scale to go down. All right, to get this back into balance, we would have to turn some of the product into reactants. All right, so there's that. Same thing if you were to remove. All right, so you take some of the product out, you remove it. That would cause the scale to go up, all right, because it'd be a little lighter. So then what we would do is we'd have to use some of the reactant to reform the product that we removed. All right, so just kind of think of it in terms of this whole like balancing thing. This is a little kind of like visual that might come in handy. So we've got our just generic equilibrium reaction. A and B are reactants, C and D are products. All right. If you are dealing with the reactants, if you add reactants, all right, we're going to try to use those reactions. So we're going to push the equation, or we're going to push the reaction towards making more products. We have extra reactants. We're going to try to use them. So we push the reaction forward or to the right. All right, if you remove reactants, we're going to try to replace those. So we want to create reactants. So the reaction reverses. It's going to go towards the left. All right. So this is the kind of the gist of what's going on here. Essentially, if you add something, we're going to try to use it up. All right. So it's going to move away from whatever you add. If you remove something, it's going to try to recreate what you remove. So it's going to, the direction of the reaction will go towards what you remove. All right. So if this didn't quite, I'd even say pause here, just kind of think about this, look over this diagram here, all right? If you're looking in this last column, it's the long arrow that shows you which direction things are really going to go. All right, but once you've had a chance to let this sink in, move on, we're going to apply this to some examples. All right, so here we have our reaction. All right, we have our reactants here, our products here, And we have some conditions. All right, so let's say I remove some hydrochloric acid. All right, so I'm going to take some of this out. I'm going to remove it. That means on my reactant side, I'm missing some components. So our reaction is going to try to replace what we remove. So it's going to move towards the HCl, all right, or towards the reactants. All right. And then if I add chlorine, all right, so if I add chlorine, that means I have extra chlorine, all right, so I'm adding chlorine, here's chlorine, I have extra of this, all right, so you can think of it as I'm adding more, so that means that's going to tell the reaction that, oh, we've got too much chlorine, all right, so then in this case, we're also going to move to the left, sorry, my tool changed on me, all right, we're going to move to use the extra chlorine. All right, so we're going to move in the direction that'll use it up, which would be to the left. All right, so if you add things, you move away from what you add, you move towards what you remove. So again, adding nitrogen. All right, so nitrogen's here. I have extra nitrogen, I'm going to have extra reactants. So in that case, I'm going to move to the right. So I'm going to move to use the extra nitrogen. All right, so I'm going to move away from the nitrogen because I want to use it up. If I remove NH3, all right, so here's NH3. I'm going to remove some of the NH3. I'm going to have less of it, which means I'm going to be short some of the products. So that's going to be, again, moving to the right. And I'm moving to the right because I'm going to move to replace the lost NH3. All right. So at this point, I'm hoping you've had a kind of an example of every sort. See if you can figure out what's going to happen with the last two. So pause the video, try those on your own. All right, so for HCl, let's see, I'm going to remove all the stuff that I've added over here. So this time I'm going to add hydrochloric acid. All right, so hydrochloric acid is in the reactants. I have extra hydrochloric acid, so I'm going to want to use that up. So I'm going to move forward to use the extra HCl. All right, you can also see these two blue ones. There was removing HCl and adding HCl. They do opposite things, which makes sense, right? Don't want this to get too busy. All right, so removing chlorine. All right, so chlorine is here. I'm going to remove chlorine. That means I'm going to be missing some chlorine. We're going to want to replace what we lost. So we're going to move to the right to replace the lost chlorine. So I hope this makes sense. There is a logic to what's going on here, and that's what I'm trying to explain. But if it's not making sense, let me know.